Homework 3.1, Quadratic Functions, Video 5. Homework due at 11:59 p.m. on Wednesday, May 27th, 2020. The following video correlates with homework questions 5, 6, 7, and 8, as did the previous video. And as with the previous video, I want to say again that you will not be asked to do all of this on any one given question, but each of these things are asked throughout the homework. So some of these things pertain to problems besides 5, 6, 7, and 8. So let's do one more graphing and quadratic function 8-part question. This time we're going to use the function f of x equals negative x squared minus 4x minus 3. Now one thing you should notice about this function compared to the one we used in the previous video is that this one is in general form. In other words, it doesn't look like this. It looks like this. So when it comes time to find the vertex, we're going to have to shift gears. And it's loaded with a lot of negatives, so you should just be careful. Speaking of negatives, is this parabola going to open up or down? The answer to that lies in the leading coefficient. The leading coefficient is -1, and more importantly, negative, meaning that this parabola will open down. Down. And this time, as we get information, I'm going to go ahead and start incorporating it in the graph, so that by the time we get to the graph, everything's already there. So again, I'm just going to draw a little upside down parabola here to remind me that that's the direction it's going to open. Next, let's find the y-intercept. And if you have a function, you find the y-intercept the same way every single time. You substitute 0 for x. This one's a little easier. The x is involved in a lot of multiplication, so anything the 0 touches will kill it. Gone, gone, and the only thing left is -3. So now we have a y-intercept at -3. So let's go ahead and go down to -3. 1, 2, 3. Put a point there and go ahead and label it 0, -3. That's why I didn't want to do the graph in advance. I have to find the x-intercepts. Well, guess what? Let's find the x-intercepts and then we'll put the graph back on. I knew there was a reason I didn't draw that sooner. You stay there. All right. So to find the x-intercepts, we have to solve the function equal to 0. That will always be the steps for finding the x-intercepts of the function. So we need to solve negative x squared minus 4x minus 3 is equal to 0. Oh my gosh, everything is negative. It would be better if it wasn't. Word of advice. If you're solving an equation, you can move stuff to the other side. It will change its sign. So before I start thinking about solving this by quadratic formula or factoring, I think I'm going to take all three of these terms and move them to the right side. Technically, you have to add x squared to both sides to cancel this, add 4x to both sides to cancel this, and add 3 to both sides to cancel this. But the net result of all three moves is we get 0 equals x squared plus 4x plus 3. And I'd much rather solve that with no negatives. I invite you to pause the video, maybe get out the quadratic formula or factor it. This guy will factor, but I'm going to go ahead and finish. To factor it, I would need two numbers that add to give 4 but multiply to give 3. That would be +1 and +3. And remember, if you're factored and equal to 0, then you can set each factor equal to 0, basically separating your x's, and then finish solving. X equals -1, x equals -3. So we do have two x-intercepts. Our x-intercepts are at x equals -1 and x equals -3. So now that we've got that, let's bring the graph back. All right. Well, all my x's are negative, so we need more space to the left here. 1, 2, 3. And our y-intercept was down here at -3. So 0, -3 is our y-intercept. One x-intercept is at -1, 0. The other is at -3, 0. I know the x-coordinate of my vertex. Remember when we developed the formula a few videos ago? The idea was to average the x-intercepts. I already know the middle of these x-intercepts, but I will do the formula nonetheless, because sometimes when you're finding the vertex, you don't have the x-intercepts handy. All right, speaking of the vertex, because this function is in general form, then we can use this formula to find it. This isn't nearly as bad as it seems. It says take the number in front of the x and stick a negative on it. Take the number in front of the x squared, double it. Whatever you get for that fraction, stick it into the function. So for the vertex, we need to start by figuring out x equals negative b over 2a. The b is negative 4, so I'm going to stick a negative on the negative 4. That will make it positive. On the bottom, I double the a, but the a is negative 1. So on the top, we get 4. On the bottom, we get negative 2. 4 divided by negative 2 is negative 2, which confirmed what I suspected a minute ago. It's right between negative 1 and negative 3. But to find the y, we just stick in the x. Now here's where you got to be really careful. My function has 3 negatives, and I'm about to stick in more. If there was ever a time to replace x's with parentheses, this is it. I'm going to rewrite the function, replacing every x with parentheses. So negative parentheses squared minus 4 times parentheses minus 3. And now I will fill in every parentheses with negative 2. Here's a mistake the best mathematicians will make if they're careless. Forget this part. What is the negative of negative 2 squared? Is it 4 or negative 4? The casual observer will go 4 because negative times negative is positive. But please excuse my dear Aunt Sally. Exponent comes before multiplication. This is a multiplication scenario. This is an exponent. It takes precedence. The negative 2 gets squared, it becomes positive 4. And then after that, after it gets squared and becomes positive 4, then the negative in front swoops in and changes it back to negative. So this first expression is actually negative 4. And without the parentheses, you would probably go as positive 4 because the 2 negatives cancel, but the square happens first. Don't overthink this. Negative 4 times negative 2 is positive 8 minus 3. Put all that together, I believe you get 1. So the y-coordinate of the vertex is 1. The x-coordinate is negative 2. So our vertex seems to be negative 2, negative 1. It is not, because I just wrote negative 1, and it's not negative 1. The vertex is negative 2, positive 1. And frankly, I was expecting the y to be positive. Why would I expect that? Because I knew this parabola was upside down. I know I'm going to sketch something that goes through both x-intercepts and turns around up here, so I was expecting the y to be positive. Let's plot the vertex. Negative 2, 1 is about here. And right away we can drop our axis of symmetry, which is that x equals whatever the x-coordinate of the vertex is. So our axis of symmetry is that x equals negative 2. And now we can find the symmetric image of the y-intercept. The symmetric image of the y-intercept. Well, first off, let's go ahead and sketch our graph. I know we're getting ahead of ourselves. But the symmetric image of the y-intercept is over here. It's down the same amount as the y-intercept, so it's down negative 3. But where is the x? Based on the fact that the axis of symmetry is at negative 2, but the y-intercept is at x equals 0, the distance here is 2. There are 2 spaces between the axis of symmetry and the y-intercept, which means there are 2 spaces between the symmetric image of the y-intercept and the axis of symmetry. So I'm at x equals 0, I go to the left 2 and then the left 2 more, which means I went left negative 4. So the symmetric image of the y-intercept is negative 3, negative 4. We've already done the graph and we can pull the domain and range pretty easily. Again, it's just a polynomial function. Its domain is going to be all real numbers. So where's my gray marker? I just capped it. So domain is negative infinity to infinity. But what's the range? Remember, range of the y values, which in interval notation goes from bottom to top. How low does this graph go? All the way forever. Negative infinity. But how high does it get? This is as high as it gets. And how high is this? It's only up 1. So the range stops at 1 and includes 1. We could have pulled out the domain and range the minute we knew the vertex. In fact, the minute you know the vertex and the direction the parabola opens, you can draw a pretty rough sketch of it. In other words, the minute I knew down and negative 2 comma 1, I could have gone to negative 2 comma 1, dropped a parabola. I wouldn't have drawn the intercepts too accurately, but it's in terms of location and direction, that's not a bad job. All right, so try questions 5 through 8 in the homework. They're about graphing, and again, they don't ask you to do all these things, but I wanted to show you all these things.